In this episode, you will learn how to create a tornado attack. Hello and welcome to how to create a vampire clone in Godot 4. So today we are going to be making our tornado. So the first thing we're going to be doing is clicking on Add New Scene, Other Node, and typing in area, since we're going to be creating something very similar to our ice spear. It's just going to function a little bit differently. First of all, let me just get my reference script up, and now we will just type in a couple of names. So we're going to name this tornado because it's going to be a tornado attack. We're going to be adding a sprite too, and I'm just going to quickly type in tornado within my files, and we're just going to add the sprite from tornado to here, and this is going to be our tornado sprite. I'm also going to be adding a collision box, and I'm just going to add a rectangle that will cover our collision. There we go. I think I'm just going to make it a bit generous, and in addition, I'm going to make this part of the attack group. And we're going to make it so that it's on the enemy layer. So the enemy hurt box is going to collide with our tornado. So I'm just going to do a Control S, and I'm going to be saving this under player, attacks, and we're just going to save tornado there. In addition, I'm going to add a timer, and I am going to be adding a audio, which is just going to be an audio stream player. We don't need 2D positioning for this. And I'm just going to rename this to sound_attack. So now that we've done this, we're going to add a script, and we're just going to add a bunch of variables to begin with. So var levels equals 1 for the level, var HP equals, we don't want our tornado to despawn from hitting too many enemies, so I'm going to make this equal 999. We're actually not going to use HP, I'm just kind of keeping this consistent though. Speed is going to equal 100.0, var damage is going to equal 5, var attack size is going to equal 1.0, and then we're going to have a new variable called var last movement, and this is going to be the key differentiation between the ice spear and the tornado. So we're not actually going to be targeting a specific enemy. Instead, what we're going to be doing is targeting, well, we're just going to be pushing towards a specific area, and the last movement is just going to be the last area that the player was facing. So we got angle less equals vector 2.0, and then I want angle more equals vector 2.0. I should probably also add a knockback amount, so knockback amount equals 100. And then as we saw in the last episode, we're going to have to make our signal for remove from array with an object. This is because from the last time we did it, the hurt box needs this signal to exist. And we're also got a onReady var player equals get tree dot get first node in group player. Alright, we are finally done with the variables. So I'm just going to be making the basic setup, which is just going to be a function. So when we spawn our tornado, we want to match it with the level. This is just going to be the first thing we do. We're going to match the level, and if it's level 1, we're going to set the HP equals 999, speed is going to equal 100, 100.0, damage is going to equal 5, the knockback amount is going to equal 100, and the attack size is going to equal 1.0, and then we're just going to ignore this for the rest of the time. Now, in terms of exactly how we want our tornado to move. We want it to move kind of like zigzagging across the screen, and we're going to be doing this based on getting our last movement. So I'm going to be going back into our player, and we're just going to be adding last movement. So we're just going to be typing in var last movement equals vector2, and I'm just going to have a default to up. And the way we're going to be setting our last movement is we're going to be going down to this, where we check if the mov isn't equal to vector2.0. This just means it moves, and we're just going to make last movement equal mov, because that is the movement. And we'll use this later when we're spawning it. Until then, we're going to go back to the tornado and start processing the movement. So I'm going to create two more variables. Var move to less equals vector2.0, and var move to more, which is going to equal vector2.0 as well, since we're just declaring it. And now we're just going to get the last movement. So we're going to make it so that this last movement is equal to the player's last movement, which I think we may as well just do here, which is just, well, I'm just going to do it when we spawn, so we'll just ignore it. So we're going to match last movement, and we're going to be detecting whether last movement equals vector up or vector2 dot down. And if it is either of those things, we're going to be setting the move to less, and this is going to equal the global position plus vector2. We're going to be then doing a rand range f for float, and we're going to be making this -1 to -0.25 for the x value, and we're going to making the last movement for the y, and then we're going to be multiplying that by 500. And effectively what this does is that we get the position where the tornado spawns at, and then we're going to add on top of this an additional 500 pixels in a random direction where this is going to be sent to. So I'm also going to do this as a move to more equals global position plus vector2 rand f. Oh, I just realized there should be rand f range, not rand f. So rand f range is going to be 0.2521 for the x value, and then last movement dot y times 500 for the y value. So pretty much it's just going to be like a range between two different positions that it's going to float between. Oops. So we also need to do this for vector2 dot right and vector2 dot left, and I'm just going to copy this because it's very similar, except we're going to be making last movement x and then rand range 1 to 0.5, and we're just going to be swapping these around pretty much. And this is how we're going to be getting the random positions the tornado is going to float between if we've got vector2 or vector left as our last movement. And then we have to do the diagonals, so vector2 1 1, which I believe would be our bottom right, vector2 -1 -1, which would be our top left, vector2 1 -1, which I believe would be our bottom left, and then vector2 -1 1, which would be our top right. And this is going to work like a little bit differently to the other two. So we're going to do move to less, global position, plus vector 2. And then we're going to be making it so that it's going to be the last movement dot x. And then we're going to have our last movement dot y. And then we're going to multiply that by a random range, which is going to be 0 to 0.75. So if it lands on 0, the y value becomes 0 and it just goes into a straight line. Otherwise, it kind of just goes into, it just ranges. I'll explain it a bit more in theory time. So that's good for that. Close off the vector 2 and then multiply by 500. And then we have to do this for move to more as well. Equals global position plus vector 2 and once again it's going to be last movement dot x, but this time we're going to be multiplying this in the same way. And then we're just going to have last movement dot y and multiply that by 500, so it's going to be flying towards something far, far away. All right, so now that we've declared these things, we're going to be setting this to we're going to be setting these variables to our more permanent variables. So we got angle less, so we're going to we're going to be getting the angles from them. So the angle we're going to be getting is angle position dot direction 2 move to less, and then angle more equals global position dot direction 2 move to more. And now that we've done this, we're going to be creating some tweens. So the way that we're going to be kind of setting it is that through our physics process, well, I'm just going to do our physics process at the moment. So function, physics process, we're going to be moving our tornado pretty much in the exact same way as we are with our ice spear. So position plus equal angle times speed times delta. The only difference is that we're going to be changing what our angle is via a tween. So var tween equals create tween. And then we're just going to be setting a random angle, and we're just going to be set angle equals rand I range, rand I underscore range 0 to 1, and this will either return a 1 or a 0. Now, our if set angle is equal to 1, then we're going to be making the angle equals angle underscore less. And then what we're going to be doing is we're going to be tweening the properties between each other. So tween dot tween property, and it's going to be on it itself, on its angle. So we're going to be altering the angle, and we are going to be altering this to angle more. And we're going to be doing this over 2 seconds. And then after this one ends, we're going to be doing another tween. However, this time it's going to be angle less. And we are just going to duplicate this a couple times. So 1, 2, and you can do more in your want. I'm just being a little bit lazy at the moment, but for the 12 seconds it will rotate between the two. And then I've got, and then if it ends up not being 1, aka it equals 0, we're just going to do angle equal angle underscore more. And we're pretty much going to be doing the exact same thing, just kind of swapping these around. So it starts going towards angle less, and then goes to angle more, and then we just, yeah, repeat this a couple more times. And then we play the tween. Tween.play. So the other things we are going to be doing for this is adding our prerequisite functions that we need to have. So enemy hit. And we're just not going to actually be using this. We just need to make sure that it exists because it's going to attempt to call enemy hit at some point, and I just want this to be here and I want to pass it because I don't want this tornado to take damage. And then we are going to have the timer, which I'm just going to set to, let's just do 20 seconds for our tornado. I'll go to timeout, and we're going to emit our signal for remove from array, which is just about clearing hit once hurt boxes, which was discussed in the last episode of the tutorial. So we have done all the code so far. We're going to go back to the tornado, but we've got something that should be a functioning tornado. The other thing we need to do is set this as top level. Just so it is, when we spawn it, it's not so much attached to the parent as it is its own thing. Oh, not show behind parent, top level. Going to control save that. And now I'm going to go to player and I am going to spawn this. And we're going to be spawning this in practically the exact same way we do the ice spear. So in attack, we're going to add a timer and we're going to add a child for that timer as well. I'm going to set this to 3 seconds for that timer and 0.2 seconds, and then we're just going to rename them as tornado timer, and then we're going to have tornado attack timer, and I'm going to make them access unique as seen. And now that we've created them, we're going to have to add a bunch of new variables, just like the ice spear. So let's start with our, I'm just going to remove this explosion so I can point to it. Number one, we want our tornado as a variable. So I'm just going to type in tornado equals preload. And then I'm going to drag and drop our tornado soon into the preload. So we have it loaded. I'm going to add a onReady vars for tornado timer equals get node, and it is going to be tornado timer, and then we're going to be doing that for the attack timer as well. So tornado attack timer equals get node tornado attack timer. And now we have to add all the ammo and stuff, so tornado. And this is all pretty much the exact same, so I'm just going to copy and paste this, and then I'm going to highlight it, Control R, and then I'm going to type in ice spear and then tornado. And what this is going to do is this is going to replace, anytime it finds ice spear, it's going to replace it with tornado. And we're just going to do a replace all. Make sure that selection only is selected and do that. And it's going to change to our new variable names. And we are just going to keep this extremely similar because we're spawning this in the exact same way. We check the level of our tornado. We set the tornado timer wait time to the tornado underscore attack speed. We set our tornado timer, well, we check if our tornado timer is stopped, and we check if, and then we start our tornado timer. So I am just going to copy and paste that, And once again, just do the same thing. Make sure it's selected, replace all. And because it's working in the exact same way. And we're going to do this once again. We're going to connect our Tornado timeouts. Though I'm just going to copy and paste our Tornado timeouts to be underneath the Ice Spear timeouts, just because they're very similar and I want them in the same place. Once again, just going to copy and paste the Ice Spear timer timeout. And we're just going to do a replace all here. And we are going to be doing the exact same thing with the attack timeout. Just highlight, replace all, and now this is all Tornado. The only thing we're going to be doing is setting the last movement. So last underscore movement is equal to last movement. And this is because in our Ice Spear, we use a target. And in our Tornado, we check what the last movement is. And now, this, when we play our scene, it should actually spawn tornadoes. Oh, one last thing though. I'm going to reduce the Ice Spear level to 0 to make sure that we only spawn tornadoes. So, oh, also, I'm going to change this to from 1 ammo to, well, 1 ammo to, I'm going to change the Tornado attack speed to 3 seconds. So we don't adjust the Tornado attack speed to 1.5. This is one of the problems with copy and pasting. You can kind of, it speeds things up a lot, but you can run into problems. So let's just run this now. And you can see that we have some interesting tornado patterns, which makes me wonder if I screwed up. So up works well, side does not work well. Okay. It's pretty clear that I have a couple of problems with my Tornado, and now we're going to try and work out what did I screw up. So, I'm just going to go to my reference script, which was working, and we can just see that this should be good. This should be good as well. Oh, I see. This should be X. There we go. There's our problem. Yes, the X value should be representative of the X value. And now when we spawn it, cool, that seems to work pretty well. Yep, so it's all kind of going in the right direction. And then when we do diagonal, all right, I'm going to call that pretty much working at the moment. All right, so that works pretty well, but there's some improvements we can do. So I want this to kind of speed up as it gets closer. As time goes on, I want this to speed up. So I'm actually going to be creating a brand new tween. And we're just going to call this var initial tween. And this is just going to be a new create tween, but we're going to make stuff run parallel of each other rather than one after another. So set parallel true. And the first thing we're going to be doing is setting the scale from 0.1 to 1. So we're just going to do initial tween dot tween property self. We're going to be setting the scale. We're going to be setting our final scale of vector 1 1 times the attack speed, attack size, and we're going to be making this happen over 3 seconds. So you may notice that there's no set trans or set ease in this. This is because I want this particular one to be linear. But in our one, we're just going to make this ease out. So set trans, I'm going to be making this tween.trans quint. And then I'm going to be setting the ease to set ease, and I'm going to be making this ease out. And that's going to be the scale. So we have to go back, go into our tornado scene, and we have to make it so that in the, I believe, it's not material, in the transform, we're going to set this to 0.1. So it is tiny to begin with. So it's going to Control S that. The other thing I'm going to be doing is with the speed. So I'm going to be getting the speed that we actually want, and I'm going to be calling it final speed equals speed. And then we're just going to be doing another tween. These will happen at the same time since we have the set parallel flag there. So the final speed equals that. Speed equals speed with divided by 5. So it's going to be pretty slow to begin with. And then we're just going to tween the property to get faster as time goes on. So self speed, final speed. And we're going to make this happen over 6 seconds. And once again, it's just going to be a set trans quint set ease out. And I'm just going to copy and paste it in there to make it just a little bit quicker to type out. And then we're finally just going to play it. Initial tween.play. And this is all happening within the ready function. So a lot of stuff happens within the ready function. And then this is the physics process. Super easy. The other thing I'm going to do is add a sound to the sound attack. So I'm just going to drag that over. Drag the tornado.og. I believe this is, yeah, it's set to loop. So I'm just going to re-import it so that loop is not selected. And I'm happy to just set that to autoplay. So now when our tornado initially spawns, we're going to play this sound once. And now when we walk, we're playing a slow moving tornado that kind of goes towards our direction. And I reckon it's pretty cool. Now, obviously, if you want to like really see it, we can increase the base ammo to like 5. And you'll see that every 0.2 seconds, it will spawn a new attack. And it just takes the last position you were in when it spawns. So if you want to walk into circles, it can go into many different directions. And that is how you make a tornado attack. Just a small post-production edit. We made a mistake with move to less. Just make sure that last movement.y is multiplied by the f range, just like x is in move to more. In a very similar fashion to our ice spear, we check for the tornado level to start our tornado timer. When the tornado timer timeout signal occurs, we increase the tornado ammo by the tornado base ammo and start the tornado attack timer. Every 0.2 seconds, we see if we have ammo, and if we do, we spawn the tornado attack in almost exactly the same way as the ice spear. The only difference is that instead of setting the target, we are setting the last underscore movement variable. The last movement variable is just a vector2 direction that is captured when the player moves their character. So when mov doesn't equal vector2.0. In our tornado, the goal is to get the attack to move in a curved wave-like fashion based on what the last movement is. After setting some stats within our level, we match the last movement direction with 2 random vectors that will be around 500 pixels in front of wherever the player was moving. I'll show a couple of images to demonstrate the range of what the values could be. After getting those random points, we then get the angle of our tornado attack between those points. This will give us the direction that the tornado needs to move in. After that, we begin tweening. We have two different tweens. The first ones will increase the size of our tween from a 0.1x scale to a 1x scale and increase the speed from 20% of max speed to 100% of max speed. The second tween is about adjusting where the tornado will actually go. First, we flip a coin to decide which side the angle will start with, and then we tween between the two angles to create a curved wave-like flow state. The movement is done in the physics process by adding the ever-changing angle multiplied by the speed and delta to the tornado's position. We have enemy hit because I made a mistake and realized in editing that we didn't actually need this, because we check if the function exists within the hurt box, so we can just remove this since it's doing nothing. And we have a timeout function that we forgot to set to auto start, which we will fix now, and this will cause the tornado to delete itself so it doesn't go on forever. The emit signal is just for the hit once hurt box type, so if an enemy gets hit by a tornado and the tornado queue frees itself, we just remove it from the array that is tracking it.